Introducing the Advanced Functions, MHF4U. This online course offers an extension of students' knowledge and skills in functions. Throughout this course, students will delve into the characteristics of polynomial, rational, logarithmic, and trigonometric functions. They will learn strategies for combining functions, enhance their comprehension of rates of change, and strengthen their ability to apply these principles effectively. Further, students will refine their utilization of mathematical processes vital for success in advanced mathematics. Designed for students pursuing the Calculus and Vectors course as a university program prerequisite, as well as for those seeking to solidify their mathematical knowledge before entering diverse university programs. Aligned with the Mathematics Curriculum Policy document for grades 11 and 12, 2007, this university preparation course carries a credit value of 1.0. The prerequisite for enrollment is MCR3U Grade 11 Functions. This course is comprised of 4 units and a final assessment as follows. Unit 1, Characteristics of Functions, 26 hours. During this unit, students will revisit fundamental concepts related to distance-time graphs, reinforcing their understanding of this graphical representation. The curriculum will involve a comprehensive review of transformations and their effects on graphs. Key concepts, such as function notation, relations, range, domain, and function notation, will be revisited to ensure a solid foundation of understanding. Towards the conclusion of the unit, strategies will be introduced to facilitate the comprehension of rates of change, equipping students with the necessary tools to navigate this crucial aspect of mathematics. Through this integrated approach, students will consolidate and reinforce their grasp of these essential mathematical principles. Upon completion of this unit, students will be able to demonstrate comprehension of average and instantaneous rate of change, interpreting and determining the average rate of change over a specified interval, and the instantaneous rate of change at a specific point, both numerically and graphically. Determine functions resulting from the addition, subtraction, multiplication, and division of 2 functions, as well as from the composition of 2 functions. Describe the properties of these resulting functions and solve associated problems. Compare the characteristics of various functions and utilize modeling and reasoning skills with functions to solve problems, including those that may not be readily solved through traditional algebraic techniques. Unit 2, Polynomial and Rational Functions, to 27 hours. In this unit, students will delve into the realm of polynomial and rational functions, expanding their understanding beyond linear and quadratic functions to encompass cubic, quartic, and quintic functions. They will analyze the graphs and characteristics of these functions, while also distinguishing them from sinusoidal and exponential functions. Furthermore, students will engage in comparative analyses, contrasting the graphs of various polynomial functions with those of alternative function types. Through investigation, students will identify key features, such as vertical and horizontal asymptotes, domain and range, intercepts, and intervals of positivity and negativity within the graphs of rational functions that serve as reciprocals of linear and quadratic functions. They will draw connections between the algebraic and graphical representations of these rational functions, fostering a deeper understanding of their behavior. The unit will also involve problem-solving tasks that require students to apply their knowledge to simple rational functions and equations. Students will differentiate between solving equations and inequalities in one variable, demonstrating how to determine the solutions of simple rational inequalities through graphing techniques and technological tools. This exploration will further involve identifying intervals in which the solutions satisfy the given inequalities. By the conclusion of this course, students will be able to identify and describe important characteristics of polynomial functions, establishing connections between the numerical, graphical, and algebraic representations of these functions. They will also recognize and define key features of the graphs of rational functions and accurately represent these functions graphically. Moreover, students will tackle problem-solving activities involving polynomial and straightforward rational equations through graphical and algebraic methods. Additionally, students will demonstrate proficiency in solving polynomial and basic rational inequalities. Unit 3, Trigonometric Functions, 27 hours. Throughout this unit, students will be introduced to the concept of radians as an alternative unit for measuring angles alongside degrees. The radian measure of an angle will be defined as the length of the arc subtended by this angle at the center of a unit circle. Students will establish and apply the relationship between radian and degree measures. The unit will also focus on sketching graphs for fx equals sin x and fx equals cos x using angle measures expressed in radians. Students will identify and describe key properties such as a period of 2p and an amplitude of 1 within the context of radians. Additionally, students will learn to represent a sinusoidal function with an equation based on its graph or properties, using angles expressed in radians. Emphasis will be placed on recognizing trigonometric identities as equations universally valid within a specified domain. Students will have the opportunity to prove these identities through reasoning skills, exploring various relationships and verifying their validity using technological resources. This unit provides a thorough exploration of the radian measure, trigonometric functions in radians, and the fundamental principles of trigonometric identities. By the conclusion of this unit, students will showcase a comprehension of the concept and application of radian measure. They will establish connections between trigonometric ratios and the graphical and algebraic representations of their respective trigonometric functions, as well as the relationships between trigonometric functions and their reciprocals. Students will apply these connections to problem-solving scenarios, tackling trigonometric equations, and validating trigonometric identities through proof. Unit 4. Exponential and logarithmic functions, 27 hours. During this unit, students will explore the connections between logarithmic and exponential equations, recognizing their inherent relationship. The unit will emphasize the correlation between the laws of exponents and logarithms, allowing students to verify these principles with or without the aid of technology. Utilizing logarithmic laws to simplify and evaluate numerical expressions will also be a key focus. Furthermore, the unit will involve problem-solving tasks centered on exponential and logarithmic equations, with an emphasis on algebraic solutions. Students will explore real-world applications, showcasing the practical significance of solving problems within this mathematical context. Overall, the unit will provide students with a robust understanding of the relationships and practical applications of logarithmic and exponential equations, offering a solid theoretical and practical foundation for their learning. By the conclusion of this unit, students will be able to demonstrate an understanding of the relationship between exponential expressions and logarithmic expressions. They will evaluate logarithms and apply the laws of logarithms to simplify numeric expressions. Furthermore, students will identify and describe key features of the graphs of logarithmic functions, establish connections among their numeric, graphical, and algebraic representations, and solve related problems graphically. Additionally, students will solve exponential and basic logarithmic equations in one variable algebraically, including those embedded in real-world applications. Final assessment, proctored exam, 3 hours. The culminating evaluation consists of a supervised 3-hour examination, representing 30% of the student's final grade. Student requirements: access to a scanner, smartphone camera, or equivalent device for uploading handwritten or hand-drawn work. A laptop or personal computer, recommended browsers Google Chrome or Mozilla Firefox. Ability to record videos and scan handwritten work via mobile phone, tablet, iPad, or webcams. Reliable internet connectivity. A non-programmable, non-graphing scientific calculator. School resources provided. Access to Microsoft Education for word processing and presentation software. Supplementary readings, tutorial videos, and instructional content are delivered through screencast solution videos. Assessment strategies. Assessment for learning plays a crucial role in shaping student learning outcomes by reinforcing the link between assessment and instruction and offering continuous feedback to students. This form of assessment is integrated into daily teaching practices, enabling teachers to gain insights into students' needs as they engage actively in their learning and assessment processes. Educators use this valuable information to tailor their teaching approaches effectively. Assessment for learning is characterized by continuity throughout the learning process, direct alignment with defined learning objectives, provision of informative data to inform teachers' planning and instructional strategies, immediate detailed feedback to guide student progress. The primary goal of Assessment for Learning is to foster the development of self-regulated learners who are equipped for lifelong learning.